My name is Deepak Saxena. Most of you probably know me, I think. I run the kernel working group at Linaro. And we've got 2 sessions back-to-back actually scheduled. We've got a ARMv8 kernel status update and sort of an ARMv8 platform update, which were scheduled a while ago. And we're just going to kind of run them as one back-to-back session. They'll cover various topics. And next to me are Katlin Marinas. Is that how you? From ARM, who maintains the ARMv8 tree, and Will also from ARM, who's been working closely with Kotlin. And Kotlin's put together sort of co-maintainer now of ARMv8, so you can send your patches to him also and heckle him. So Kotlin has put together an outline, and what we're going to cover today is basically the status of ARMv8, the kernel, sort of what's coming next in terms of what features still need to be developed, and also a little bit about the platform support plan, how that differs from the 32-bit ARM code. And then also sort of have it open for Q&A. I know there are a lot of people here who are currently working on ARMv8 platform code or SOCs, or will be working on them, or will be porting existing drivers or whatnot to ARMv8. So we'll kind of also have just an open time to discuss whatever people want. And with that, I'll hand it over to Kotlin.
Okay, hello everybody. So try to put some bullet points. They're not really slides, but yeah, just to keep myself focused. And so the current status, probably know, the core architecture has been merged in the 3.7 kernel. So that was just the ARMv8 support without any SOC, and the development was done on a software model that emulates the Versatile Express pretty closely. And there are additional patches which are still not in the mainline kernel for running on that. So in the second part, I'll talk about the SOC support. As for the features, so the core features are there. There is SMP support. We support 4K and 64K pages. With 3 levels and 2 levels of page tables, depending on the page size. And we have VDSO, which is used for SIG return, and we have optimized get time of day. Do we have anything else in there? No, yeah. So yeah, the get time of day is a very useful optimization. You don't need to do a system call just to get that. You run the code in the VDSO, which reads, it expects the generic timers to be there, so it relies on that feature being available in hardware, which I would expect on all ARMv8 processors to have generic timers. Our debugging, what we used was the model debugger that comes with our RTSM model, and that was for early bring up. And most of the time, we just use early print K, really. We don't bother with graphic debuggers. And since then, we had lots of cleanup, bug fixes. Alviro actually doing lots of patches to clean up the signal handling, the K-thread creation, and some other system calls, compat system calls. And we had to actually test them. Most of the time, they were correct, but yeah, we still had to fix some issues and work without. Did we have any other features since we? Since 3.7, yeah, I don't think we had any, no.
Just fixes. I mean, there aren't that many people developing for it at the moment. So.
Yeah. Well, the new features we expect, so the KVM patches have been posted by Mark a couple of days ago. We have started some work on CPU hot plug and using this power state coordination interface. Huge pages, I have some patches for huge pages. I don't actually like how they look because they just duplicate the x86 code. So I started creating a common huge TLB implementation, moving the x86 one into the generic directory, and that could be shared by ARM, 32-bit ARM, and 64-bit ARM. I didn't have time to complete. So in terms of debugging, yeah, there is plan for working on kprobes, ftrace, kgdb. We haven't started any of that yet. there will be some ACPI work coming from the Linaro Enterprise group. This contiguous memory allocator, it may be needed at some point. I haven't got any requests for that, but yeah, I would expect we may need it. It's, we don't have hardware yet, primarily targeting on Model S. So as more partners develop and they show up with their hardware, we expect to get requests for more features. So that's pretty much the current status. You can go into the SOC. Yeah.
So one question I have for you is, are there any other areas in the 32-bit code that you think will have commonalities with the 64-bit code as we move forward? Someone was mentioning, with Big Little, for example, some of the Big Little IKS stuff right now is written specific to 32-bit, but this SOC vendor imagined that they may have Big Little V8 systems down the road, so we'll end up having to move that out of 32-bit code into sort of somewhere common. Are there any other places you can see that happening or foresee that happening?
For Big Little, I would expect NP to be the primary target rather than in kernel switcher. There are other features that are being developed for 32-bit. I don't have a list now to see, but yeah. What?
Yeah.
Yeah. Does this work? Yeah, it works. So yeah, for Big Little, I would expect to have, if we ever get such platform, I don't know what our partners are doing, use the Big Little MP. There may be more features in the enterprise field, maybe like NUMA, which I'm not sure. Maybe some features we'll get first on AR64 before we get on AR32. It's just, we are targeting, maybe targeting different markets with AR64, like server space being the primary one, and then mobile. The multi-cluster aspect, yes, we'll probably have something, but maybe built around the PSCI, Power State Coordination Interface, for CPU booting and hot plug. As I said, I don't expect something like in kernel switcher. We may have multi-cluster systems, but targeting server space rather than having something used for power management to migrate between a big and little system. So something like more, homogeneous clusters in there.
Yeah, I think the other thing to bear in mind here is it's not just new features that we need to worry about. It's if code is improved in ArchArm, then what we really don't want is to have people have to do that improvement twice, because it'll either put them off doing it in the first place, or they'll just do it in one place. Especially with things like bug fixes, we don't need code to be fixed twice. So I don't really have a good solution for that, but we do need to avoid duplicating files particularly. And if that means moving it to somewhere common, then I'm sure that's a good step.
Yeah, the SOC is a good example of moving it under drivers, so I'll talk about it in the second part. Now, another set of patches which I forgot to mention are optimized library code and atomic bit operations. So we had them in development in ARM, but when we started the public review, I dropped them just to keep the code simple. And now people are asking for that back. People who got access to our kernel when it was all private, now they are asking for those features back. And hopefully in 3.10 we'll get some optimized library code and bit ops pretty much written in assembly.
Okay, before we move on to sort of the SOC platform, are there any questions anyone else has about general ARMv8 support?
So at the moment with 3 levels of patch. Oh yeah, the question was whether we can have 4 levels of page tables and what's the maximum virtual address we can, was it the virtual address that you're asking? Yeah, so with 4 kilobyte pages and 3 levels, we can get 39-bit per user, 39-bit per kernel. So that gives you 512 gigabyte virtual address space for user, and the same for the kernel. With 3 levels. With 4 levels, you can get to 48-bit, but I haven't seen any need for that at the moment. If we get some platforms with lots of RAM, like terabytes, yeah, we will add support for the 4th level. With the 64 kilobyte page configuration, I kept the same 39-bit address space with 2 levels, but actually can easily expand it to 42-bit address space with just 2 levels. So it's very easy on the TLBs if you need 42-bit address space. The disadvantage of the 64 kilobyte pages is that you can't run the ARMv8 applications, so you can't use compat because of some ABI requirements in the 32-bit world that are assuming 4K pages.
Okay. One of the questions that was asked to me by someone in the hallway, Mark, maybe you can answer, related to KVM, is right now what's supported? 64-bit guest on 64-bit host, or 32-bit on 64, or both? Yes.
So the answer is globally yes, yes, and yes. Okay. Could add a maybe as well. So yeah, we support 64K guest, 64K guest on 64K. Basically, all the 4 combinations are supported. That has some requirements on how some peripherals are mapped into the guest, but that's for V8. That's a requirement anyway. Yeah, so basically works in all combinations. It's been tested.
Okay.
Yeah, so far so good. Yeah.
Thank you. Any other questions before we move on to sort of the SOC platform story? Looking at you, John.
Yeah, I'm just thinking, do we ever hit this somewhere, other things remaining that people can throw ideas at?
That's part of what I'd like to get from here also, is what are features that member companies and other people in the community, silicon vendors, are wanting to see supported that may not be on this list and may not be even on our radar. There's things that we're going to validate. So part of what we're going to do in Linaro is some of these features on here, like the debug features, K probes, ftrace, U probes, the kernel team at Linaro is going to take on. And I think as we start bringing more or the ARMv8 stuff into our CI loop and start enabling some of the server distribution configurations, we'll probably hit issues. But I think there's nothing core that should be needed. It's not like we have to go make changes to some of the security layer or some other layers in the kernel. Say again?
System call auditing?
System call auditing,
For example?
for example. Is this something you perhaps are looking into? Okay. So I think we'll find those issues as we go and as we start deepening testing. But I don't think I can't think of any other features right now that are like, oh, these are architecture-specific features in the kernel that need to be implemented.
So I think the other thing is if anyone has private things they want to say to you, because some people do, right?
Yes.
Reach out to you, is that the best thing?
Yeah, I would say reach out to me and reach out to Kotlin also, depending on the various NDA things that are in place by different people. So let's talk about the SOC platform part of it, because I think that leads into a little bit into some of those questions that might come up more in private.
Okay, so they have one of those. Yeah, so currently it's not in the, so the mainline kernel doesn't support full SOC. You may actually be able to build in the 3.9 kernel. If you don't use SMP, you may be able to build an SOC kernel because the gig has been moved to driver circuit chip. Now I have for various SOC patches, primarily targeting our RTSM model. I have a branch in my tree. Plan to get rid of most of those patches in the 3.10 kernel. What we support now is Versatile Express, which is our RTSM model, and the KVM tool, which doesn't actually need much, or doesn't have any SOC code, just some VirtIO drivers to be enabled. There is no, so we made the decision to have no platform code under ARMv8. I know some people say, oh, okay, well, where is the Mac directory or the platforms directory? So decided to, okay, let's remove this, get everything into drivers, try to have single image. We don't have that image. The single image by default. And there isn't a way to identify, okay, I want this SOC built into the kernel. Now for Versatile Express, I had to add a kconfig option because code under drivers just depend on this ARMv8 kconfig entry. But otherwise, you shouldn't have some common place where you say, this is the code for vexpress for initializing. There is no machine descriptor. So every platform is split and in a set of drivers scattered all over the place. You can build, if you want some machines, several machines, SOCs to be supported, just build those drivers into the kernel. And now the drivers would be either self-probing, so they may have an arch init call or core init call in there, which we actually had to do for Versatile Express. Or for most of them, they would be driven by the DT, device tree. So device tree is mandated for now until maybe at some point we'll get ACPI as an alternative. But so far we have DT. The gig has been moved, thanks Rob, has been moved to drivers IRQ chip, and now it's initialized via this OF IRQ init. And that's probing the DT and getting the right configuration for the gig. The secondary gig initialization, that's done, it's a patch I have, a set of patches I have in my tree. They are done via CPU notifiers, so it doesn't make sense to have the SOC code. Since gig is a separate driver now, initializing on its own, doesn't make sense to have the SOC code to call gig secondary init. So I moved that into the actual gig code. I hope to get it merged into the 3.10 kernel. Yeah, so the timers is the same for local timer initialization that's done via the CPU notifier. There is an interesting race here because we want the gig initialized before the timers. So we use the priority feature in the CPU notifiers. Make sure the gig gets first. That's record on actually on ARMv32 because the timer probing needs some delay calibration, and we use interrupts. We need interrupts up to it. Don't think it's needed for 64-bit. Now the clock code, so Versatile Express is I'm not sure, I'll just say is the best example, but it's a good example on how all the code has been moved into drivers, and that's what we use for the 64-bit for the ARMv8 support. And the clock now is moved under drivers clock there, and we have, as of 3.9 RC1, we have this clock OF declare. So where you declare the clocks, you no longer need to actually call the clock initialization from your from some common SOC code. You do clock OF declare, and there is an arch init call for which does the clock OF init. That's in the 64-bit code. And I have a device init call for the OF platform populate, which actually populates the device structures from the DT. There is another interesting race here because populating the platform devices from the DT, it requires the clocks to be already enabled, which is a bit weird, but it was required for some AMBA buses where you can't check the prime cell ID unless the clocks are up. So we really need to have the clocks initialized before actually populating the platform devices. So drivers that need to be initialized earlier than OF platform populate. So then a device init call can use an arch or core init call. We have an example here with a vexpress sysreg. So Pavel Molinarm, he created kind of driver for an MFD driver for the system registers on Versatile Express, and everything else, including the clocks, they use those that sysreg driver. And they had to be initialized before actually the clocks. So there is a core init call added in the vexpress sysregs driver. In terms of booting, so what we had on ARMv8 is every platform having pretty much its own plat SMP or doing its own booting protocol. On 64-bit, we decouple the SOC for the booting protocol. So you have a booting protocol specified in the DT. We don't let any platform implement their own. If they really need a special booting protocol, they can add the bindings and we may implement it, but they need to have a good reason for having yet another booting protocol and not using one of the ones that we define. We have for now two booting protocols implemented. Is the spin table was the first one, so it's pretty much the secondary CPUs waiting in a loop, polling some memory location, and the primary CPU writes a flag in there, an address where to jump to. And this is all defined in the DT. The other option, which is more useful for some big platforms, for example, where the CPUs may be in a low power mode before they start, and we are moving here to using the power state coordination interface. This is an API to the secure code on your SOC if you have EL3 implemented. So pretty much do an SMC call, which should release the secondary CPUs. A PSCI covers more than just CPU booting. It covers hot plugs of CPU off, CPU on, CPU suspend. We don't plan to support CPU migrate, which is done for big little, but hopefully we get big little MP working if we ever need this.
Well, you should as well.
Yeah.
This is not for the switcher. This is also used for hot plug.
Oh yeah, yes, you're right. I think I was always hoping that the secure part would just cope with calls on all the CPUs, but there are some cases where the secure firmware may expect, or if they have some secure OS doing keys or whatever, sometimes they expect calls only on CPU 0, so if you use CPU hot plug, we may need to migrate, unless they can actually handle the CPU off calls. So, yeah, I'm not entirely sure. We need to handle the CPU migrate just to tell where the secure firmware where to move itself, whether it can handle the CPU off on its own.
Well, I suppose that if you want to hot unplug CPU 0 and keep the system running on CPU 1, you still need to have secure wall service in your call. In that case,
Yes, so yeah, if
CPU 1.
yeah, but whether the secure firmware may be able to detect this via the CPU off and know which cores are online. And if the secure firmware is fully MP aware, it may be able. Otherwise, we'll see when we get there. I don't say we will never implement CPU migrate, but
Okay, but my point is just that it is not related to the switcher.
okay, yeah, that's a good point. Yes. So yeah, just to repeat in case it wasn't clear, Nico's saying that CPU migrate is not necessarily related to the switcher, but it can be used in other situations for CPU hot plug and telling the secure firmware where to migrate to. Okay, so going back on the booting protocol, we expect, so if you want to use the virtualization extension, we expect the kernel to be started in EL2. And there has been a discussion on UEFI on how this is being done. For guest OSs, we support PSCI using the hypervisor call, the HVC instruction, which would be handled by the hypervisor code in EL2. And as I said, the booting method is driven, now the enable method is written in the fdt file, in the DTS path to the kernel. So we can actually even support, I haven't tried that, so some CPUs using PSCI, some others using the spin table method, but yeah, we haven't tried this combination. In theory, it's possible. There is no early init call for SOC, so I haven't seen a need for that yet. We'll see as more hardware comes, but on ARMv8, we have a way via the machine descriptor to do some early initialization. We don't support this on AR64. We are trying to get SOC vendors to push as much initialization as possible to the firmware. So if you have some auxiliary control register bits, some implementation defined bits, or some errata workaround, some chicken bits as we call them, they really need to be pushed to the firmware. We don't want the kernel, because the kernel doesn't have the information that early on which SOC it is running. It can detect the CPU version number, but doesn't mean much in all situations. People may apply some ECO fixes to their hardware, or they may have a way to work around CPU bugs by doing SMC calls, which we don't know. There is no standard way of handling that. So we really want to push that early initialization into the firmware. So on Linux starts, everything is set up like you have SMP enabled. We used to have an SMP and AMP bit on, we have it on ARMv8.
Yeah, I'd also add that since we want to be entered in EL2, that's non-secure, and a lot of these registers you can't access from non-secure, particularly for writing. So we just don't want to go down that route at all, really.
Well, we've been cornered already on ARMv32. We're already in a very bad place because we have SOCs booting in secure, where we can actually apply workarounds. We have a number of SOCs booting in non-secure, where we basically can't do a thing, and we end up being cornered with a multi-platform kernel, where if we enable any errata in the kernel, these kernels won't boot, simply on the OMAP, for example. So we're trying hard not to get into that situation for AR64.
No. There are lots of things which should be done at runtime, like errata workarounds. It requires extra barriers or extra whatever instructions at runtime. So those would be added to the kernel. But there are sometimes there are undocumented bits that the hardware people put in the CPU. So when we have some problem, they can disable some speculation or some other things. And those bits are usually in registers that can only be accessed from secure mode. Yes. Yeah, of course, we can't. There are many errata that require runtime fixes, and that would be part of the kernel. But at least you can enable them much later when your kernel boot and you can detect more. Some of those bits we have to enable before the MMU is enabled, and at that stage in Linux, there is no way you can parse the DT to figure out what platform you are on. And there is no way to actually do an SMC call because you don't know what the firmware is handling just for those bits, especially since there are registers which are not documented. So yeah, if the secure, non-secure, if EL3 is implemented on an ARMv8 system, we require Linux to start in non-secure mode and have that's because the hypervisor, the EL2, is on non-secure side, so we want to use the virtualization extensions. If you started Linux in EL1 on the secure side, there is no way it can switch itself to the other side. On ARMv8, on AR64, if you start in EL1 secure, you need an an SMC call to go to year 3 before going back into year 2. So there is no easy way like you have on ARMv8 where you can change the mode from SVC to monitor mode just by writing the CPSR register and be able to switch to hypervisor. So what other patches are left to be upstream is this gig secondary CPU interface initialization, which I'll post probably next week. I'll repost on the Linux ARM kernel mailing list. There are some Versatile Express patches, so I'm moving the archarm mac vexpress reset.c file to drivers power reset. That's a new directory that has been created, I think, in the 3.9 RC1 kernel or 3.8, I don't remember exactly, but it takes code responsible for power off and restart. There are some patches from Pavel Mol on clock initialization for AH32. I have them in my tree. They will go into mainline in 3.10. And there is a CLD driver to be converted to the DT. I cherry-picked some patches from Linaro, and they work for me. I'm not sure what form they will get into mainline. I don't think I've seen them on the list, or maybe they are posted in the past. Pavel is planning to either clean them up or push them upstream, I don't know, at some point, but yeah, Pavel is maintaining vexpress code, so I'm waiting for him to do that. And of course, I'm waiting to see contributions for AR64 partners. People are still developing this in private, so I haven't seen any patches yet. It would be good to sync up, see if you can get in touch with us directly, even if you don't want to disclose it, just private emails. And if you have any issues on how the SOC is supported, especially since we don't have any platform code under the ARMv8, there may be some difficulties in porting the 64-bit kernel to your SOC, so please get in touch with us. And it's, yeah, me, Will, Mark for the architecture. There is the Linaro, the ARM SOC team, Arndt, Olof, Deepak. They can help on SOC issues and how code should be moved to drivers.
Yeah, and I think I want to sort of reiterate what Greg said at his keynote at the very end, which is he gave the example of the Intel and how they by the time they release hardware, the support for not their SOCs, for their chips and for the devices is already upstream. And I think it's really important that we strive as Linaro and as a community and as an industry to move to that model for the AR64 work. I know there are different member companies out here. There are different stages of getting their SOCs up and running, and I do have some concern that some of the folks who are coming from 32-bit SOCs and they're just sort of drop replacing the core with a 64-bit core are probably just going to take their existing 32-bit ports and just try to get them running on 64-bit. And as we made it clear here, that's not how we're going to be doing things in 32-bit. We'll be really separating the idea of the processor core from the idea of the SOC itself and how do we manage those and how do we describe those. So the earlier you can get involved with ARM and letting Kotlin and his team review the code, or if you want to work through Linaro, whichever way you want to do it, the better for you as a silicon vendor and for us as a whole ecosystem, especially with the whole ARM server movement, that it's really important that we get this code upstream as soon as possible.
Yeah, one thing I'd say there is, despite the differences, we are reusing the Linux ARM kernel mailing list. It doesn't seem to be any point fragmenting that community. So if you do post upstream, yes, yeah. So post to the Linux ARM kernel mailing list if you want to post publicly. We don't have a separate mailing list.
I just make one thing very, very clear for anyone who's doing development on a port to AR64. If you want support in a distribution like Fedora, we only use upstream kernels. So if you have your random port that's wonderful and great, and it doesn't do exactly what these guys just said, you won't be supported in Fedora at least, or anything derived from Fedora in the future. So just make that very clear. Okay.
And the same, I won't speak for other distros, but I'm going to assume, I think we can make an educated guess that the same can be said for other distributions that may not be here right now. Any questions or comments or concerns? We have the room for another half an hour or 40 minutes or so. Jeff? So the question, if I understand, is what's our plan for getting some of this stuff into the CI loop at Linaro? So that's actually an action item that I already gotten from. I had a sort of a private discussion with Kotlin about what are we, where are things at, and what are we doing at Linaro. And so Linaro did this release late last year or early this year, where we put out basically something you could download, which was a fast model and a disk image. And I don't know that we've followed up and continued to build those. So one of the actions that come out of the discussions here is to make sure that we get that up and running, and we're doing some sort of regular builds. What the ideal, from my perspective, is when we do our monthly releases and we do our monthly and our regular CI loop runs, that we're pulling in AR64 and we're building that, and maybe we can work with John and other people to get the distro builds also into our system, so we can provide something for testing.
Yeah, I'd like to see longer term Linaro as the central point. You can get a full mini distro for AR64. Like get a tool chain, you get a kernel that has been testing, and you get a file system so you can just put on your platform and run. And this would be tested like continuous integration and have monthly releases. So I see Linaro just the central point for downloading all those.
How do you plan on avoiding code stopping at Linaro then? If that becomes a one-stop shop, how do you avoid code getting stuck there and not coming?
Well, I expect people to, so the question was how do we avoid code being stuck at Linaro? So I would expect both Linaro and partners to develop against the mainline kernel. So my view of contribution, someone developing code, they should take the mainline kernel to do their development rather than developing against the Linaro distribution. And they own the code until it gets upstream. I've seen this with some partners or people even in ARM contributing to Linaro, and they forget about the code. They think, okay, we sent it to Linaro, it's upstream for us. It works really well for project managers, because they said, okay, tick, I've done the box, we contributed upstream. Linaro doesn't have the resources to actually, it's really hard for someone in the ARMs, in the lending teams, to take someone else's code and try to upstream. It's really difficult for them. So I expect people to own those branches. So if Linaro can act as something like the Linux Next in their continuous integration, so I keep pulling that SOC code from that company into the Linaro's continuous integration. Linaro doesn't own that code. It's the responsibility of that SOC vendor to own that code until it gets upstream. It should be very clear. They don't give it to Linaro and they say, job done. No, they own the code until it gets into the mainline kernel.
I think it's the responsibility of Linaro to make sure that delta against upstream is as small as possible.
But you just said you're looking for people to have the one-stop shop to go to Linaro to get all this.
Not for development. Right. If they want something like, you want a file system, where do you get it from? You start building BusyBox, you want a tool chain, where do you get it from?
Okay.
So I see they go to Linaro and they can get a kernel that has been tested if you want to do some validation.
Right.
If you want to do development.
So do you want to answer that question?
Okay, see.
So let me clarify a little bit from my perspective. So I've had people come up to me from silicon vendors and say, which version of Linaro kernel should we use to do our port or for our platform? And just to clarify, the Linaro standpoint is that we do not want you using our kernel as a starting point for your ports for upstream. We want you to be working directly against upstream. The purpose of the Linux Linaro kernel and the builds that we do is not a starting point for development. It's sort of a place to basically be able to grab something and say, I want to be able to start playing with this, so I want to give this to my developers who may be doing something at a higher level than the kernel. They may be doing some user space development. They want sort of a somewhat tested baseline to do that against. Now, I think what Kotlin is pointing to is that as more and more people start getting up and running ARMv8, they're going to want a place to go and say, where can I get a basic file system to start running with? And that's what we can provide with our build. So here's a basic file system, and we're doing these engineering builds that we're basically going to provide that. And here's a tool chain that we've sort of done some basic validation on that people can start using. And here's a kernel that maybe you can start using to do some quick testing. But if you're doing brand new work, we definitely want you to send it directly to the community. And you can send it to us to sort of do help with early review, especially in the cases where, okay, maybe you're not ready to have your code reviewed publicly in the community. That's a place where I hope we can help out working closely with Kotlin and his team.
So just on this clarification. So yeah, if you are developing new kernel code, just take mainline. You may want to integrate it into the Linaro's continuous integration testing. But no, development you do on mainline, you may once it's in the Linaro CI, you may want to try that kernel as well, which has been tested. But you just don't get rid of kernel just because Linaro integrated it. You own the code until it gets into mainline and do development against kernel.org tree.
So is Linaro planning on testing vanilla mainline as well on ARM64?
So we can do that. So one of the things, we had this session yesterday on how can our QA services better help kernel.org, and one of the things we talked about is we want to pull in -next. So we could also add, in addition to building 32-bit kernels, build the 64-bit kernels. Yeah. Okay. And there was something you said which I wanted to speak to, which I can't remember right now, unfortunately. But I think just to reiterate, yeah, we want people to be sending things upstream. We don't want people to be using our CI build as a starting point for their upstream development or a starting point for product development. It's really sort of meant to be a little snapshot that you can start playing with and using. And we will definitely, and we'll push back if people come to us and say, here's some patches, can you just take them? Now, there are cases where we've taken patches that are not upstream yet, and part of that is what we're doing is we're creating a little sandbox. Well, here's these two features that aren't upstream yet, and what happens if we put them together and people start playing with them together, and we can find bugs there and give those bugs back to the developers, whether they be developers in the community or they be developers at Linaro or they be developers at member companies. So it's more of a place to test things together and not to sort of be the landing point.
Is this code flow documented somewhere? Like, is it really obvious to someone that this is what you should do, how you should do it?
No, it's not. I wanted to start documenting this internally in ARM as well to get the understanding better, but I'm not aware of any. I think Linaro may want to, the Linaro landing teams, they can put something on the Linaro wiki for that. I think Linaro, how Linaro can help here, avoid this confusion, is say we don't own that code. If someone sent us some code, some partner, okay, we integrate this for this monthly release, we drop it immediately after that, unless you send us another version, so we don't own that code. I see people doing development against the Linaro releases, and they develop incremental patches on top of the Linaro kernel, and they keep sending that to the Linaro, okay, please integrate those extra patches on top of your kernel, and I think it doesn't help Linaro, doesn't have the SOC vendor, so Linaro should just drop it. Someone like the Linux Next, so I integrate all those branches now, but the SOC vendor owns that branch until it gets into mainline. So you had a question?
I'm actually glad that this came out because, I mean, like, actually people are using, our core members and club members are actually using our kernel to do their integration as opposed to the other way around. So, I mean, like, I think it should be an action item for at least the landing teams of those companies to make sure that they understand that.
So I think another action item that's coming out of this is, so we have right now in the wiki and the Linaro wiki, and a lot of our member companies, their engineering teams are looking at sort of Linaro as a place where they can sort of get some of this tribal knowledge that's out there in one place. So we have some documentation. How do you make a 32-bit port multi-platform capable? So I think an action item is to sort of do something like that, which basically takes this document Kathleen's put together, maybe do some more details in here, and also describe the workflow so that when our member companies do start saying, well, we want to do a 64-bit port, we're working on SOC, how do we get started, who do we talk to? We can at least point them to a single place and say, here's the workflow, here's the, and list who are the people, who are the maintainers in the community, how does the work that you're doing with Linaro fit in with the work that you'll be doing with the community, and really clarify that for everyone who's involved. Any other questions or comments? Oh, you're online, Arnd? Oh, can you, anyone on IRC right now?
Let me get that.
Can you get an IRC with, okay.
So that document, I would say it's very high priority.
Mm-hmm.
Thank you for expertise.
Yeah.
Here's what you do.
Yes.
Having a link when you go to clone any Linaro kernel, there should be a giant thing saying, "Do not do this."
All right.
Can we have an MOTD?
MOTD.
When you clone, yeah, when you get pulled.
We have that on like on the Fedora for Chromebook. It says, "Do not download this."
So,
There are two things in the document. One is, the technical side, how to do the port, and Linaro has been doing this for 32-bit. And the other is the workflow, getting them separated, getting the workflow clear.
Arnd, I think we can hear you.
Can you hear me?
Yes, we can hear you.
Okay. So I already typed on RC now. So we're almost at the point with the 32-bit platform code that we can have an empty platform definition there as well. And we will probably soon get to the point where any new platform is strongly recommended to have an empty platform definition, which then can be identical 32 and 64-bit because it's empty. So all the drivers could be in the drivers directory, and then any platform that is supported on 64-bit will also be supported on 32-bit.
That makes sense.
Starting with hyper.
Anything else? Arnd, any other comments?
No, I think that's the only one for now.
Okay. Anyone else in the audience? Any other comments, questions? Okay. Well, thank you all very much. I know Kotlin is leaving this afternoon, but I'm here until the end of the week. And when are the two of you leaving?
Oh, tomorrow.
You're leaving tomorrow. So, if you do have, if
I'm leaving
now,
this afternoon, around 12, so I still have a couple of hours if people want to talk about this in private.
yeah. So if you're someone who's doing a V8 port, Silicon bring up or whatnot, and you do have some questions they don't feel comfortable talking in here, please grab someone in private. Thank you all very much.